Okay, so 10.2. Operations with matrices. All right, so first example. The only thing you need to know for this example here is that two matrices are equal only if they have the same exact inputs, same values in the same places. So solve for x and y. So they have a matrix here, and they're saying that this is equal to the other matrix. And we said that that is only true if all the inputs, all the values in the matrix are the same. So that means x has to equal this value, right? Y has to equal this one. I think I wrote that wrong. Let me double check. Yeah, this is supposed to be a 25. Not that it matters. Okay. All right. Example 2. So just remember, the only thing you need to know, it can only be equal if all the entries are the same. But matrices can be equivalent to each other, even though they're different, but that's not the same as equal. On next example here, problem 6. A is equal to the 2 by 2 matrix, -1, 2, 1, -1. And B is equal to 1, 2, -1, 8. So first part, what they want us to do, I'm going to have to change pens here, is add A plus B. So when you add matrices together, they have to be the exact same dimension. You cannot add matrices if they're not the same. Like if this matrix was a 2 by 3 and this was a, I don't know, 5 by 5, you can't do it. You would just say no solution. Okay. But in order to add them, you just do component by component, right? -1 plus 1, 2 plus 2, 1 plus a -1, -1 plus 8. So that will be 0, 4, 0, 7. Not too bad, right? Part B. A minus B will be the same thing, just put a minus in the appropriate spot. So it'd be a -1 minus 1, 2 minus 2, 1 minus a -1, -1 minus 8. So you get -2, 0, 2, -9, right? Part C, you can also scale a matrix, kind of like when you do vectors back in pre-cal, or in physics 1, you'd see vectors. I don't think you've seen vectors yet. in math. Anyway, 5 times A means you scale every entry by 5. So you look at the A matrix and you multiply it by 5, by 5, by 5. And that's it. Now, you can do all these operations on your calculator if you want to. You would just define a 2 by 2 A and a 2 by 2 B, and then do the operations. That's it. Anyway, any questions on number 1 or 2? All right. Let's move on to number 3 here. Okay, switch to a different pen. Problem 8. All right, so here they're asking us to solve for x. So it's a little weird, but if you think about what we've been doing, it's not too bad. It says 2x is equal to 2 times the matrix A minus the matrix B, where A is defined as -1, 1, 3, -4, 5, 4. Matrix B is 4, 5, -3, 2, 4, 2. All right. So we could do this operation first right here, 2a minus b, and then divide by 2 on both sides, right? So this would be the same as 2 times, I don't know what x is, but we can just call it x1, x2, x3, x4. This is my x. I just called them whatever. I don't know what it is. That's equal to 2 times a, which is -1, 1, 3, -4, 5, 4. Minus the b, which is 4, 5, 3, -3, 2, 4, 2. All right. So I'm going to not mess with this 2e just yet. Just leave it there. So multiplying by 2 means you're going to scale the entire thing. So that'll become -2, 2, 6, right? Everything times 2. -8, 10, 8. Minus this guy. All right. Combine those two matrices. This would become -2 minus 4, 2 minus 5, 6 minus a negative 3, negative 8 minus 2, 10 minus 4, 8 minus 2. So this would be negative 6, negative 3, 9, negative 10, 6, 6. All right, at this point, just divide both sides by 2 or multiply by a half, right? So this matrix again divided by 2. There we go. Hold on a second. Let me double check everything. I think we're good. So our x, right, is equal to everything divided by 2. So this will be negative 3, negative 3 over 2, 9 over 2, negative 5, 3, 3. So we did matrix multiplication right here, the scaling. So we subtracted them here, got this. And then we got rid of that too, because they wanted to know what x was. I just called x these 4 things, right? Although in hindsight now, it was actually 6 things. So this was a mistake. Darn it. Let me see. Not that it matters, but it should be more proper. Let me fix this. I don't want to erase the whole thing. Okay. Sorry, guys. This is annoying. There we go. So we're solving an x that is actually a 2 by 3. Okay. Anyway, so this question kind of brings it all together. It makes you do addition, subtraction, the scaling, and solve for x. Any questions on number 3? Okay. Let's move on to multiplication of two matrices. I'm only going to do one of them because you can do this on your calculator. And I'll show you how to add and subtract and multiply just a sec on your machine. Okay. If possible, find A times B, where A is -1, 5, -2, 5, 0, 4. And B is equal to 4, 3, 0, 9. So in order to multiply, the inner dimensions need to match. So this is a 3 by 2. 3 rows, 2 columns. This is a 2 by 2. So see how these are the same? If those are the same, you can do A times B in that order, not B. You cannot do B times A. I mean, you could, depending on the question, but it might not work, and it will definitely not always be equal. So A times B is possible because these are the same. This is how you do it. So the resulting matrix is going to be 3 by 2. So the outer dimension is going to be the result. So this will equal. So what you do is go row by column, row by column. So -1, 5 times 4, 0. -1, 5 times 3 times 9. Then you go to the next one. -2, 5 times 4 times 0. -2, 5 times 3, 9. Last row. 0, 4 times 4, 0. 0, 4 times 3, 9. So this will be my new matrix once I solve it. Okay, so it's going to be -1 times 4 plus 5 times 0. Let me show the actual multiplication part. Okay. So -1 times 4 plus 5 times 0. This will be the new entry for this corner here. Okay. -1 times 3 plus 5 times 9. -2. So you always do this number times that number plus this times this. Okay. -2 times 3.
-6.
Yeah. It's going to be -6 for sure. Okay, make sure I didn't miss anything. This times that, 5 times 9. Yeah. Last row. 0 times 4 plus 4 times 0. It's not very lined up, but oh well. 0 times 3 plus 4 times 9. So once you add all this up, you'll have your new matrix. So -4 plus 0, there it is. -3 plus, what is that, 45? -8 plus 0. -6 plus 45 again. 0 plus 0. 0 plus 36. So this would be your new matrix. That is going to be a 3 by 2. So you go from 3 by 2 times 2 by 2. If the inners match, then the result will be 3 by 2, which is this. I'm not going to make you do this by hand, but I want to at least show how to do everything by hand, just in case. So, let's go back a bit. So for 2 by 2s, just go to edit, put your dimensions. The first one is, let me see, -1, 2, 1, -1. Okay, to quit and go back into the menu, create a new one. Oops, go second, X inverse, edit, go to B. 2 by 2. 1, 2, -1, 8. So quit. Now there's 2 saved. So all you got to do is go in there and press enter plus B. And there's the result that we found earlier, right here. You can go back in there and then put a minus in the middle, and that'll get you this guy. You can also do 5 times a matrix, which is this one. And if you're going to multiply matrices, you would just simply do times this it. A times B. Anyway. So if you want to use a calculator, you can. I'm not going to require work for the chapter 10 exam. Okay. But if it's wrong and you have no work, then that's on you. Okay. Can you guys see the homework?
Yes.
Okay. So right here, if you notice that the dimensions don't match, then you just stop. Say it does not exist. Okay. So this is a what? 3 by 2, right? This is a 3 by 3. So the inner ones are not the same, so I cannot do A times B. So you would put possible. That's it. Then we're not going to get a new size matrix because we can't multiply. So you would put impossible there too. Okay. That makes sense. Here you're going to multiply A times B and B times A. You can do that by hand like the way I showed you, or you can use your calculator. And you're going to see that multiplying in two different directions is not going to be equal. It's going to be different. A times A would be A squared, so multiply this twice. Don't square each term, just multiply it twice. You can see it's not square. It's not that easy. But yeah, that's pretty much it. The rest is the same stuff. Multiply AB, multiply BA over and over again. This guy, yeah. Do you have any questions on adding, multiplying, or scaling a matrix? This seems straightforward, or does it seem difficult?
Pretty straightforward. Just take some time to like write everything out.
Yeah, it can be tedious. I think I told you the exam should be, I think they're all 2x2s, or I don't think there's any three. Or I think it said it was either 3x3 or less for sure. There's no 2x2. No, no 4x4s. I'm sorry. Okay. Anyway, so let's look at the next one. Plus 10.2. 10.3. There is a long way to solve this by hand. But first, let's do this part right here. They want us to prove it. Prove that B is the inverse of A. Yeah, let's do that one. Let's move on to the next section. The inverse of a square matrix. So only a square matrix can have an actual inverse. So if it's not square, you shouldn't be talking about inverses. Here's a note for you. A and B are square matrices how should I phrase that? A and B are inverses of each other if and only if A times B equals the identity of dimension n, or actually, and it's an and statement. And B times A is equal to I n. Where A and B are of n by n dimension. Yeah. There we go. So the easiest way to say this is just to show you. Show that A times B. Hold up. They phrase it this way in the homework. Show that B is the inverse of A. So in order for A to be an inverse, we have to multiply them together in both directions, and they have to give you the identity in both directions. So 2, 1, 7, 4. And B is 4, -1, -7, and 2. So to show that the are inverses, A times B has to equal the identity. If you saw the videos, you should know what IN is equal to. If not, I will show you in just a second. So basically, this has to be 1, 0, 0, 1 when you multiply it in both directions. So let's see if this is true. I wrote it like it is, but I don't know if it is. So just punch them in your machine. Second x inverse. They're both 2 by 2s, so 2, 2, 1, 7, 4. 2, 1, 7, 4. Ah, dang it. Go edit the B. 4, -1, -7, and 2. Okay, so they're both in there, saved. Go back into the matrix menu. Enter times A times B. So we got the identity matrix. Ones, you have to get ones along the main diagonal, zeros everywhere else. So then you do it again in the other direction. Is B times A the same? Okay, so they are the same. So since A times B is equal to B times A, which is the identity matrix of dimension 2, then A and B are inverses of each other. So that's how you check. Does that make sense? Just multiply AB, BA. If you get this, then they are inverses. If one of them is not one of these, right? If one of them is different, not the identity, then they are not inverses of each other. Any questions on example 1?
So basically, we're just checking if they're inverses.
Yeah, you're just verifying it.
Oh, okay.
Or proving that they are inverses. Same thing. So next question, let me show you how you find the inverse. I'd prefer to use a calculator for this. I think both work. Let's see if this one works too. I'll put it around the light. Okay. So 2 by 2, 4, 1, 7, 2. Saved it. Go back into the menu. Math. Yeah, there's an inverse button. So call the matrix first. And then go back into the menu and call the inverse. that'll solve for the inverse for you. So the next question is find the inverse. Well, there is a procedure on how to do it, but I'd rather you just use the inverse function. Anyway, you are not guaranteed an inverse, by the way. So it might give you an error or so I guess let me mention a couple of things. You will only have a matrix if an inverse of your matrix exists only if it is square. But it's not guaranteed to exist. So it might be square and it still might not exist. Okay, so you can try to solve it and then you might get an error, which means there is none. You would just say it does not exist. Done. If it's a 3 by 2, you would say it's not a square matrix, so I cannot talk about inverses. Does that make sense?
Can you say that again, sir? I'm sorry.
Yeah, I'll write it down for you. So note here. A may see there's a better way to say this. Only a square matrix can have an inverse. That is to say, n by n matrix. That's what we mean by square. Number 2, a n by n matrix may not always have an inverse. Just in case it wasn't clear, n by n means square. This is the dimension. Row by column. So the rows match the columns, it's square, obviously. And only those could have an inverse, but it doesn't mean they exist. So any non-square doesn't have it. Okay, so I'm going to show you a formula that'll help you find an inverse for a 2 by 2. Given a matrix A equal to lowercase a, b, c, d, A inverse will equal 1 over AD minus BC times D times negative B, negative C, and A. What number are we on? 2. To find the inverse of A equal to let's see. Let's do the one we just did. 44172. So A inverse would equal 1 over A times D minus 7 times 1 times, switch the D and the A, so it'll be 2 and 4, switch the signs of these two, -1 and -7. So this will be 1 over 8 minus 7 times 2, -1, -7, 4, which is just, this is just a 1, right? Now just do it down here. 1 over 1 times 2, -1, -7, 4. So you could use this formula to find the matrix, or you can use the inverse button or inverse function on your calculator. Up to you. This formula does not work for 3 by 3. Only 2 by 2. Any questions on number 2?
Yeah, I have a question.
Mhm.
Where is the inverse button on the calculator again?
Which calculator do you got?
TI-84.
For 84, you can just call your matrix, right? So just press enter on the A and then go to that same button right here, the X to the -1, and that'll find it for you.
Thank you.
The older one, I don't know if you could straight up use a button. Maybe. I don't see an inverse button. Although I'm wondering if it would understand if I put a negative power. Oh yeah, it does. Cool. So you could do a power and do -1, or you can go into the matrix menu, go to math, and use inverse button right there, inverse function. Either way.
How did you do it for the TI-84? I'm sorry, that was kind of quick.
You call your matrix onto the main menu. So you go into the matrix menu, press enter on your A or B or whatever,
Okay.
and then press the X inverse right here next to the sign.
Okay. All right, thank you.
Okay. So one more note. If you have a matrix equation, so given an n by n matrix, A an x variable or vector of n by 1 dimension and a row of a column of constants of n by 1. Let me write it out. So this is called the matrix equation. In general terms, if you have, let's say, some numbers here, right, going down all directions, multiplied by some vector, or in other words, a column of variables, all the way down to an and xn, equal to some bunch of constants. B1, B2, B3. Then you can use the inverse of a matrix to solve for x. So what you can do is multiply x, A inverse times A x on both, on the left only, right? Left multiply. These will cancel. Solving for x. So this is how you would use an inverse to solve for your variables. So basically, if you multiply the inverse times the constants, you will get x automatically. That's what this is saying. So given a equal to -1, -1, -1, -2, -2, 2, -1, 2, -3, 2, and this system right here, which is going to be made out of these coefficients, x plus y plus z equals to 0, 2x plus 4y plus 3z equal to 2, 2x plus 5y plus 4z equal to -2. Okay. So basically the matrix equation would be 1, 1, -1. Sorry, this is an inverse, by the way. 2, 4, 3, 2, 5, 4 times the variables x, y, z equal to your constants. So we call this A, X, B. Does that make sense what I was trying to say up here? You convert your system into a matrix equation. So if I multiply this thing here, the constants, by this, you will get X automatically, right? That's what this is saying in general. So basically, X is equal to A inverse times B, which is equal to 1, 1, -1, -2, 2, -1, 2, -3, 2 times your B. So multiply this out and you will get, this is a 3 by 3 and a 3 by 1, which means we will get a 3 by 1. Right? Remember we said that the ones on the outside will be the result. You can only multiply if they match on the inside. 3s. So once you multiply, you will get 4, 6, and -10. You use your calculator, or you can multiply like I showed you, row by column, right? Although doing it by hand kind of sucks, so that's up to you if you want to do that. Anyway, so this formula here uses the inverse to solve for x, y's, and z's. Any questions on example 3?
So that 3 by 3 is just the inverse of the first matrix up there, A, right?
Yeah, then this question they gave us A inverse. We didn't have to solve for it. If you were not given this, you would have to identify A, find the inverse, and multiply by B.
Oh, okay.
But on this first one, they gave it to you. I think the last question in the homework, they want you to find it, but it's a 2 by 2 instead, so it's not as bad. Because finding a 3 by 3 inverse by hand is like probably 2 pages of work, depending on how complex it is. Which is not horrible, but it's annoying.
Should we should we during the homework do this by hand or does it matter?
It doesn't matter. What matters is, do you understand the concept? Like, can you identify the dimensions of the matrix? Can you identify when you're able to multiply them? Can you identify the dimension of the result? And the rest can be done with calculator. Now, that's what matters to me. You can also use your formulas to shorten it up if you want, but I would recommend calculator.
So and it's probably a little early to ask, but so like during the test, are we gonna do this with calculator or by hand?
That's up to you. I won't require, like I said, I'm not going to require work. So if you want to do machine the whole time, you can. If you show your work, then I'll grade your work like usual.
Okay, thank you.
Okay. So that's pretty much it for 10-2. They're going to ask you, can you identify if two matrices are inverses? I think it's 10-3 actually, right?
Yeah.
Yeah, 10-3. Yeah. So they're going to ask, given A and B, can you prove that they are inverses of each other or whatever? Then they're going to ask you, can you find an inverse given a square matrix? Then they're going to ask you to use that inverse to solve for X and Y and Z, or just X and Y. That's pretty much it. I think we covered everything for that section, all the ideas. Also, don't forget to note that AB times BA, these are not usually equal. Sometimes they are, but that's just, when it is equal, it's just either it's because they're inverses or by just pure luck. Okay. Don't assume that it commutes like real numbers do, right? The real number system is commutative. Matrix algebra is not. Does that make sense?
Yeah.
There's many. I'm sure maybe you're not familiar, but there's many different types of algebra systems. And they don't always have the same rules as the real numbers do. So the basic algebra that you learn growing up is the algebra system for real numbers, but there's a system for matrices. There's a system for binary. There's a system. There's all kinds of systems. There's also, if you studied high level mathematics, they go as far as to create a generalized system for any system. So you create an algebra of algebras, I guess, called abstract algebra, which is kind of cool, but If you're not going that far, don't worry about it. Just want to make sure you know it's not always like the real numbers. Okay. That's just one system. Okay. 10.4. All they want you to do is find the determinant. Determinant is pretty easy, actually. The section is pretty chill. Okay. The determinant also, it needs to be a square matrix to find the determinant. Okay. The determinant of A, or also written this way, is equal to you know what, let me phrase this more legit. When you're writing math statements, it's like writing a contract, it has to be exact. Otherwise, it's not going to work. If you leave room for any kind of loophole, then it's not right. So given a 2x2 matrix A equal to, let's say A, B, C, D. The determinant of A is A times D minus B times C. Also written like this. Okay. AD minus BC. So example 1 is really straightforward. Find the determinant of A equal to 4, 7, 2, 9. So the determinant of A is equal to 4 times 9 minus 2 times 7. So 36 minus 14, which is, what is that, 28.2? Yeah, that's it. Your calculator also has a determinant function. Well, for a 2x2, it's pretty easy, so I wouldn't really use this. But when you have a 3x3 or a 4x4, then yeah, I would rather do this. What is it? 4729. 4729. So go to your matrix menu. Once you've inputted your 2x2, go to math and hit determinant, DET. Go to matrix, choose your matrix. It's going to be 22. So it just does this formula. Both calculators can do it. The cheap one and the graphing. Okay. There's not really much to do here. Find the determinant So the determinant of A would equal to -3 times 0 plus, minus 0 times 7. Any questions about determinant? It's not too bad, right? Let me show you the homework. So the whole thing is just basically that over and over again. Find the determinant. 7 times -9 minus 4 times -7 is -35. We did this one, -3 times 0 minus 7 times 0. Do a fractional one, same crap. It's just fractions. Here they're going to have you do the A determinant, the B determinant. Then they're going to have you multiply and find A times B. And once you have that result, find the determinant of that one. So same stuff. Now the 3 by 3 is the one I'm telling you should use your calculator. Like it's not too horrible by hand. I don't like it, but I'd say a scale of 1 to 10 for tedious. It's like a 5. So it's up to you. Okay. Would you like to see how to do this by hand?
Yes.
Okay, let's do it. The only time that it's worth it is when you get to when do you do that? I think pre-cal. If you do a cross product of 3-dimensional vectors, then you're basically doing a determinant. So that's the only time it's worth doing by hand. Very, very rare.
You know, this will be like on 2412 math 2412.
Yeah. It'll 2412. They will have vectors. They won't have any matrices, but they are similar. And there's a cross product of 2 vectors that is basically a determinant of a 3 by 3. They don't mention it or call it that, but it is the same thing. There's a whole algebra of just matrices called linear algebra. Then they go in depth into that material. So here we're just playing with them for a little bit, so you're exposed to them because they're very handy for solving complex systems of equations or optimization problems. Okay. So to find the determinant of A, what you do is you basically circle this guy here and cross out everything in that section. So I'm going to go across this way. So I'm starting at the -1. So I write down the -1, and then I find the determinant of this inner part here. So I cross out this corner and I do the inner determinant. So 0, 1, 1, 0. Now I go to the next one, the 2. I cross out that middle part in the top row in the middle column, and I multiply by the determinant of the outer parts. And then this is a 0, which is great. That means whatever I do, it's going to be 0. So cross out those two. 1, 0, 0, 1. Everyone see where these came from. Let me try to color code this. I'm low on pens here. I think I have a better color. Oh, here we go. This is much better. Okay. So the green is crossing these out. The blue is crossing these out. The red is crossing these out. So when I'm doing the red one, I do 0, 1, 1, 0. That's where this came from. Doing the blue, I do 1, 0, 1, 0 here. Doing the green, cross those out. 1, 0, 0, 1. Okay, so that's weird. My green pen disappeared. Oh well, who cares? Figure that mystery out later. So determinant 0 times 0 minus 1 times 1 plus 1 times 0 minus 0 times 1. You know what? Let me show you the actual multiplication. I'm gonna put them in brackets so you can see it. 0 times 0 minus 1 times 1 plus 2 times 1 times 0 minus 1 times 0. The only thing I forgot to mention is when you have to do every other sum, you have to swap the sign. So it's plus, minus, plus. This one had a built-in negative from here. So it's just -1. This was a 2, but I got to switch to negative. It's just the rule for doing these inner products. 1 times 1 doesn't matter, right? Because it's going to be 0. But we'll show it anyway. So this would become -1 times -1 minus 2 times 0 plus 0. So the product, the determinant is a1. Okay. Any questions on example 3?
On that +0, was that a -0? And then you said you changed the sign.
It's going to be So when you're going across doing these products, it's going to be plus, negative, plus. You don't have to start, you don't have to go through the top. You could go downward and then cross them out that way, but we don't want to get weird since we're just, this is the first time doing it together. So plus, minus, plus.
Okay.
But if you were to go downward, it would be plus, minus, plus. All right. Plus, minus, plus. Anyway. But yeah, I would just say plug this into your calculator and do this function. You'll get 1. But that's pretty much it. The whole section is pretty short. I think that might be the easiest homework. I hope. I'm not, you don't have to do 10.5. I'm going to disable that one. No worries on 10.5. You guys have any questions on 10.2, 3, or 4? Is it all right? Okay. Well, that's pretty much everything. That's the last section for this class. We're done. Not crazy. So Thursday, I'm not gonna have any class next week. So Thursday we can do review for. Oh, you know what? It doesn't really matter. Let me think.
You said you were gonna